Hello, everyone. Do everyone hear me? Okay, nice. So my name is Kevin Thierry, and I'm going to present you how we handle multi-user support in an embedded secure environment in Tizen-free automotive. At first, this presentation should have been given by Sabera Jeti, who is one of my coworkers, but she couldn't make it here, so I'm replacing her. So I'm going to first introduce what are the needs for in-vehicle infotainment, and then I'll explain all the part of the solution we use in Tizen. I will begin with user management, so what are the different kind of users we have. I will explain the application framework, which is the main part, the most important part. I will then talk about multi-seat, so how do we handle the different seats in a car, and especially how do we move from one seat to another. Then we will talk a bit about resource management, for example, Wi-Fi, Bluetooth, everything that allows someone to connect another device. And in the end, I'll make a summarize about what is the status of the implementation, what works, what remains to be done. I'll have a small conclusion to summarize all I said before. So the main need for IVI is multi-seats. By multi-seat, we mean we need to have several users that are going to use the system at the same time. So we have one user on one seat with one user station. So what we want absolutely is to have user station separation. We don't want a user to mess up with understand user content and application. And we need to be able to manage privilege. We need to have a user which will have more privilege to control and configure the main resources. And we need to manage the peripherals through Wi-Fi, Bluetooth, but it can also be USB ports. So user management, we have three types of user. We have the privileged user, regular users, and guest users. The privileged user, of course, is the one who is kind of the administrator. He is able to install common application. Common applications are accessible to all users, which means regular users can use common applications. Regular users can also install application, but there will be only user application. If a user installs an application, he can only use it, and other user can't access it, can't use it. And regular user, as I said before, can use common application. The guest user is a bit particular because it's the user you'll have before logging in. So it has a very restricted access to application. For example, the guest user will be able to turn on or off the radio, but maybe he won't be able to configure it or change the station. Of course, if we have a user with separate user environment, with a separate application, we have separate databases to manage the application and the packages. The difference between a package and an application is that a package can contain several applications. Package is really the archive you're going to download and install on your system. And you can have several applications in one package. Regarding package application, package installation, we have what is called pre-installing. Pre-installing, in fact, means we are going to copy the package from a shared area to a user area. Basically, user area is the home of each user has its own home. And pre-installing is copying the files and initially the databases. We have database for the package and the application. And when we want to install it, we will use the pkg cmd command to really install the application so we can launch it after. Every application is unique. In fact, two users can have the exact same application installed, but it won't be the same binary. Each one of each user will have it in his own directory. So we need to have a unique application ID, so we add the username to the application ID. And the application ID is itself composed of a package ID and the application name. About the package installation, we have different type of packages in Tizen. WGT, XPK, they're both web application. The difference between the two is that XPK is for crosswalk application. Crosswalk is the web runtime engine. And what we wanted is to have only one installer for all the different packages. So we're using a PKG CMD and PKG MJS server. And we then use different backends to install those different packages. Here we can see that there are only a few steps that are different from a package to a package from another, which incompress the archive, which is quite obvious. You can have different format, and the manifest parser. Every package has a manifest. By manifest, it's just generate a text file. It can be JSON or XML, and it contains the application name and several other information that are needed to install the package. So here we can have XML, JSON, so we need different parser. When it comes to generate a symbolic link, it's very particular to a web application, because when you launch a web application, you don't launch the application, you launch the web engine, the web browser. So your binary won't be the application, it will be the web runtime engine that will then load the application. And the main motivation behind that is to manage the security independently of the package. You want to have a uniformization of the security. So if you add a new kind of package, the security will be handled the same way for all packages. Here, in the lowest part, you can see the package manager server on the different backend, how they interact with the security manager server. The role of the security manager server is to set the security label on the files. So right now, I'm not sure it's something that is used. Right now, they're statically set. But in the end, we aim at having the security manager server being able to set automatically the label for the security. Labels are used to prevent a user from using another user application, for example. When it comes to launching an application, so a user wants to launch an application, and it will communicate with the AMD daemon. The AMD daemon will know which user launches the application, asking for the communicating with the AMD session agent. Every user, when he launches its user sessions, launch an AMD session agent whose role is to communicate with the AMD daemon. And then we can see that AMD will know which application database it has to use, depending on which user launched the application. So multi-seat. The objective in multi-seat is to be able to switch from one seat to another without losing the application, without having to logging off, which is the actual way to doing it on a desktop. So also when you switch from one seat to another, you need to be able, you need to prevent user from interacting with another user content. So we keep the user session separated. So a user has one user session. It's not a user session that is shared amongst users. But we use only one Western service for all users. So to achieve that, we just imagine that we have a big display. And this display is separated into several other areas. And those areas are displayed on the screen of the users. And we prevent the cursor or the application from leaving those areas. Like that, we can easily switch from one seat to another. We just have to move the application from one area to another. And the application framework should be the one who has the role to move the application from a display to another for Western. So there is only one issue with FOSDEM management is to manage the conflicts. For example, if one user wants to set a particular IP on the Wi-Fi device, another wants to set another IP, we need a way to prevent that issue. So the solution is quite simple in the end. It's to have only one privileged user that can configure it, which is kind of the administrator, as I said before. Another thing that needs to be taken into account is to define shared and exclusive resources. For example, if I connect my phone with Bluetooth to access my files, maybe I don't want to share it with other users, and I don't want them to access it. And you also have the opposite case where you want to share it so anybody can access it. So we need to have a way to configure that and to configure which user can access what. So yeah, I'm going to summarize what has been done and then what remains to be done. So we removed all hard-coded paths, UID and GID in application. A lot of applications were running with hard-coded username in them. So almost everything has been removed because there are still some developers that are adding it back. So it's kind of an endless job. Regarding security management, we don't have a SMAC label from legacy code from 2002 because the security framework totally changed from 2002 to 2003. And right now, we define a privileged user with the GID system. In fact, if a user is part of the system group, we consider him as a privileged user. But that's a rule that can be changed quite easily. That's like a choice that has been made, a quick choice that has been made, but it's not something that can be changed. Regarding user databases, no databases are separated. So each user has his own databases regarding his application in his home directory, and common application has a database that is accessible to, in fact, in a shared area. And the binary to initialize the databases are done and are working. The C API, the core API, now is duplicated for the function linked to application management. We have the one we had before, and that's the exact same one, but we had the UID. So we can pass the user ID to the package managers. This is needed because a lot of daemons are running as root. So if you want to get the ID of who is using it, if you run the get UID, you just get the root UID, not the UID of the user. That's why you need to pass it as a parameter when you call a core API function. The multi-user feature is almost complete in the media packages. I will talk about that later and give an example. And we can easily install and launch application. I gave the example here to install an application and to launch it. So PKGCMD is just a command line, but of course it's just for developer. So what remains to be done? The display management is not quite done yet. For example, we'd like to have the privileged user being able to move an application from one display to another, or launch directly an application on another user display. A simple use case would be a parent who wants to play a video for his child who is sitting in the back, and so he doesn't want to launch it on his screen, but on the screen of his children. Security management, we need to set correct permissions right now. So I think the security manager is almost done. So it should be done soon. And share data between applications from the same package. Right now, all applications are isolated from one another. All application data is isolated. So what we want to do is to share data between applications from the same package, but only from the same package. Regarding media server, I said it was almost done. In fact, it's possible to use it in a multi-user setup if you're a regular user, not as a common application. Yeah, so what remains to be done is manage the database for common application for the media server. So all multi-user feature in non-media package remains to be done, which means we need to manage the database mainly, or to set it up, or to set it up properly. On Bluetooth is kind of maybe the most difficult task. Right now, only the first step is done. You can connect your phone, and only you will have access to it. But there's a lot of things that remains to be done. For example, sharing it with other people. That's kind of a difficult task, which remains to be done. And YNet is not yet also ready for multi-user. So here is the example of the media package. In fact, what changed between multi-users, or what we have right now and what we had before, is that right now we have two databases that are in the user environment. Before we had only one database, and we didn't have the CAPI media content, the CAPI function that was duplicated. So, in fact, we had only, it was like if we had only one user, and everybody was using the same thing, the same database. And just for information, so media server manages your media library. So media scanner just scan for your files, and media thumbnail create miniatures of the media you have. So to conclude, here are the API needs and what we did to answer them. So we separated user sessions with an individual environment, so we don't share one session for everybody, and one common environment, so we have a base with base application for every user. We have one Western service in order to move from one seat to another. And peripheral management is done mainly by privileged user, but we can allocate resource for a special user, or we can give some control to another user. And regarding privileged requirements, here we have a security manager which gives permission access to some files, to all files. In fact, all files have a security label, and that's a label we decide who permits to allow or prevent a user from launching an application or even just reading the file. So I put all the documentation regarding multi-user on the application framework we have on the wiki. If you have a technical question, like very precise, or if you test and you saw bugs, or want to get involved, I put the dev mailing list. It's very active, so just ask, you have an answer very, very quickly. If you have any question, I'm ready to answer them. Yes? Can you repeat, please?
Systemd.
Yes.
Systemd containers and namespace.
I don't think we're using systemd containers. I'm not sure about namespaces. In fact, I didn't work much on multi-user, so I don't have all the technical details about it. But that's a question that can be asked on the dev mailing list, I think. I also know people who are working on it, so maybe I can put you in contact with them. Any other question? Yes? Sorry, I don't hear you. That's a good question. Technically, yes. Yes, you can have more than one. Nothing prevents you from having more than one. But you end up having the same issue that we're trying to prevent. For example, if you have two privileged users connected at the same time, and they both want to change the IP address of your Wi-Fi device, you end up with the same issue you had before. So it would be better to have only one privileged user. But there is nothing right now that enforces that. Yeah. Yeah, yeah, it's sort of an administrator.
I would like to become a privileged user.
You can become a privileged user.
Okay, but you know, I'm a
In fact, you could, because you can still join like the system group, but in a product, I don't think it's in the workflow to move one regular user to privileged user. I think you'll have one privileged user that you will have at the beginning, and then it will control everything else. Yes?
Could you have to think about getting the root ID? You said that
Maybe I can put the.
I didn't get it.
Which one is the best? Okay. In fact, when a user launches an application, it can launch an application or it can connect to a daemon. And daemon are run as root. So if this daemon needs to write data specific to this user, needs to know which user launched the application, so where to put the data. We want to put it in the home. So, but the daemon has no way to know which user launched it. So we have to pass through the core API the UID of the user. So the daemon know which user, or the service know which user launched it, so where to put the data, in which home directory. That's the reason. Because, for example, for Bluetooth, you can't have one Bluetooth daemon for each user, because it's generally one Bluetooth daemon for one device, one Bluetooth device.
You just find the user by just get the user and what user rights.
In fact, everything goes through the UID, user ID. Yeah, yeah. So if anyone wants to talk more about that, or other Tizen aspect, even Yocto, because I worked a lot on the Yocto part, we can talk after outside of the room. Thank you for your attention.